Hello and welcome in my man cave and home office. My name is Henk Vlootman. I'm CEO of Quanto and I'm a 10 years MVP data platform. I'm co-writer of the book Extreme DAX. I do conferences and I write blogs. This is our agenda for this session. We start with an introduction, talking about Power BI models, DAX. Next part will be row context, query context, talking about filtering with DAX, filter context. Very important are the DAX table functions, and we will end this with an example where we combine all the contexts we have used in this session. This is our 5-layer model for business intelligence. Mind you, it's business intelligence, not only Power BI. And we use those 5 layers as a framework when we talk about business intelligence. You need to keep track of all of those 5 layers. The bottom layer is the connect. And within the connect, you're searching for the way you want to get your data in. So that can be organizational files, that can be Excel files, that can be files from internet, all types of data you want to connect with. Next level is prepare. And in prepare, you just massage your data in the way you want to have it. Data is not always perfect when it comes in your BI program. So you need to make the changes in order to let it function. Third layer is analyze. That's the part we're talking in this session. In analyze, we're creating calculations. We create relationships between tables, and we do everything in order to get your visualization done. The layer 4, visualization, uses all the things you have done in the previous layers in order to get your insights. And to share your insights, that's the 5th layer. In Power BI, it will be the Power BI service. And there you distribute your insights within your organization. Let's talk about relationships. Now, we like to talk about relationships in the way that it is completely different than you might expect from a database program. In a database program, relationships will be calculated. It's a constraint, and that has a good reason to have that. But in Power BI, relationships doesn't rely on calculations. You can create them any way you like, and how they work, I really don't know, but they are really fast. That means that talking about relations in Power BI, there's one thing you need to remember. You can connect every kind of table, but there is no structural reference within Power BI. That means if I got a dimension table, which has a value that doesn't exist in my fact table, that should not be a problem for Power BI. It will return a blank row with the values in it. In a database program, this will be completely different. Here you need to have your entry in your dimension table and before you can add a record to your fact table. That's a completely different way of thinking. Since relationships in Power BI are not calculated, be aware that they are fast, really fast. That means if you look at a normal scheme, as you look over here in our context FTA scheme, you can have, of course, a star scheme, but if you have a snowflake scheme, it doesn't matter. The relations are that fast that you can have multiple connections before you got to your fact table, and it will still be very, very fast. Having said that, this is a representation of two fact tables and one dimension table. We like to call this dimension table a filter table, just to distinguish the difference between a filter table in Power BI and a dimension table in the database world. So looking at this, you can see it's a normal relationship, a one-to-many relationship between my fact table 1 and my fact table 2. And I also added a measure, an aggregation. I sum both columns. As you can see, in my fact table 1, I got the result of 140, and in my fact table 2, I got the result of 100. What will happen if I filter my date table, for instance, on the 1st of August 2022? Well, at the moment I will do that, you can see that all other dates in my date table will be ignored. I just filtered one row. The relationships to both sides will propagate that filter. That means that my fact table 1 will be filtered and give a result for my sum measure of 10. And the same will happen to fact table 2. And that means that I will have a result of 15 in both. This is one of the key elements why you never ever want to filter on your fact table, because if I should filter my fact table 1, the filtering result will not be propagated. The direction will be from the date to my fact table 1. So I only filter fact table 1 and I never filter fact table 2. Which means that if I use both measures in a visualization, that the result will not be correct. So now we know a little bit about relationships. Now we're going to talk about the context. And where do you find context? Well, the context will be in your calculations. Calculations in Power BI is called DAX. DAX stands for Dynamic Analytics Expression. You can use DAX in several different parts of Power BI. You can use it in a calculate table, calculate column, or in a measure. Most of the time we talk about measures because a measure is used in a visualization in order to make that visualization dynamic. So if the user selects different filters, the visualization will be adjusted to the filtering you have. And working with context means that you find a balance between calculations and filtering. Explaining the row context is reasonably simple. As you can see here, here's my sales table. And it consists of 5 columns. I got a customer ID, I got a product ID, I got a number, I got an order date, and I got a unit price. And in order to show you your row context, you create a new column. And with every DAX, as you know, it all starts with giving it a name. So here I could say that my amount is, and then I want to have my sales table, and I want a number from my sales table, and I want to multiply that with my sales table unit price like this. So this DAX will create a column for me, and over here, and this column will just be my sales number times my sales unit price. So row context is the context in which rows are computed. So it's calculated by row, and if you look at row context, it will in this case look at the values of my column number times my unit price, and that will be the result. Be aware that the row context knows everything about a row, but only that row. Values above or below that row are not recognized. That means that you cannot compute a value from row 1 to row 2, because in the row context only row 1 exists or row 2 exists. The query context is the way how your results of a measure is filtered. And by default, every measure returns only one value. So the value of my amount by category or in my table, total amount is displayed at the total at the end, and it is 38.5 million. So in our page, we got three kinds of visualizations. First of all, we have a slicer. Second of all, we have a bar table which contains the amount by category. And third of all, I got a table. And we talked about this table. This will be by year and month. So looking at those three, all those three will be interacting the moment I'm going to filter things. So if I start by filtering the region East, then all my measures will be changed to the region East. And you can see here that the total of region East is 9.5 million. But it's also true that if I use an object within a visualizations, like the bar of equipment, you can see that it's 22 million. If I click on it, you can see that the amount which goes around at the bottom of my table is the same 22.164 million. If I take region South with it, then you can see that the region South, filtered by the equipment, will return 5.6 million amount revenues. So if you look at what is the query context is what you can see, what happens with your calculations. Keep in mind that that is not only true for a visualization, it's also true for a DAX measure. So in a DAX measure, you still have the query mode. So the recap of the query context. The query context is the combination of selections and filters in a report that determine the result of a measure. As you can see, if you look at office supplies with 1.2 million numbers sold, it will be influenced by the region, it will be influenced by the year, and it will be influenced by the numbers sold by month. Keep in mind that the query context is the normal state of mind of a context situation. Another example of the query context, it can be found if you look at a calculate column, new column in a table. So here's my sales table. And if I add a new column over here, and I add a formula in it, like this one, what I'm going to do is that I'm going to sum my amount columns in my sales table. And since I'm in the query context, this will be the result. The result of this formula is the total of my amount column. It will calculate all the elements in my amount column, and the total will be displayed in each row of my table. Two slides on filter context. The first one is, let's try to explain what filter context is. Filter context is a context that will be transformed by DAX. That means it's something like a calculation you take and you use filtering in your calculations. Filter contexts behave like a query context. That means the moment if I filter something in my measure, that measure will react as being a filter on that part which I explicitly set in my measure. The main problem of a filter context is that you cannot derive a filter context what you see in a report. Because if you're looking in a report, you see the measure, and the measure itself is the filtering element. And that makes filter context a bit complex. When you start working in the query context, calculate will be one of the DAX functions which you certainly will use. It's a special DAX, and I'll take the time for you to explain what it does. As you can see, I have an example over here which says my sales west, and it will calculate my sales. My sales is a measure that totals my sales in my table sales. And the customer region is west, is that part of my customer table that will be filtered. Remember, since there's a relationship between my customers and my sales table, if I filter my customer table, my sales table will also be filtered. Now, what does calculate do? To start with, it does four things. The first thing it does, it's create a filter context. That means if you look at the table, each row in a table will then be a filter. The second thing is that it will remove filters from column or tables that are referenced in the filter arguments. In this case, customer region will be, if there is any filter on that column, it will be removed. Very important to understand, because it means that if you look at the complex part of it, the result will always be customer region west, although you might select, for instance, east in the slicer. It still stays the customer region because it removes that filter. Okay, then it adds a new filter. In this case, it adds the customer region west. And if that has been done, the last part, it will then compute that expression in the new filter context. So whatever you do, you will get the results back of the customer region west. One of the functions of calculate is that it can act as a switch between your query and your filter context. So the number of filter arguments in calculate can be blank. That means there will not be selected any filter. But by then, keep in mind that the query context will be replaced by a filter context. And as you can see in the next example, as a consequence, DAX measures will behave differently. Not all, but most of them will behave differently. Keep also in mind, if you have measures within a DAX function, something like divide my measure sales by my measure number sold. There will always be a calculate read around it. That means, without seeing it, the quilter theory, the quilter context will be changed to a filter context, and that means that a measure that way will always be evaluated into a filter context. Let's see what calculate does in changing your query context to a filter context. It's easy. As you can see here, I have a query context formula, and that formula does nothing else than it sums my sales amount. And as you can see, this happens in the query context, and it means that I can see the total over here from the complete amount column in each row. Now, if I add a new column like this, and within that column I use the same function, but I wrap it in a calculate. So as you can see, it's now my filter context column name, and it's a calculate from the sum of my sales amount. And what happens if I enter this one? Calculate will change the query mode to the filter mode, so each row is a filter. And that means if you look now at my filter context, it will be the same as my amount, because each row is a filter. In this demo, I'm going to show you what the filter context, calculations, measures does in the query context. And therefore we have a similar kind of tables in front of us. The first one is filtered by the category, and the second one is filtered by the product. So this is our product table, and our relation column will be the product number. It has the unique numbers, and we have a category and we have a product. And from those from this table, we're going to work in our filtering. So we can back in our visualizations. Let's first of all look what our measure number sold, which is placed in both tables, will do. And it will just sum from our sales table the numbers. And then we got two other measures. The first one is number sold all products, like this one. And it says, okay, number sold, and we don't allow a filter on the product table. The other one, number sold all products and naive, does the same, but in this case, we're just saying we remove all filters from our product column in the product table. Now let's see what happens. We just start with the number sold all products measure, and we will place it with our table, below table, which is filtered on our products. And as you can see, you got the total results of all products here. And if I use number sold all products naive, and I'll place it with it, you can see it will both be the same numbers. But what happened if I go a little bit above and I'll do the same in the above table? So I get number sold all products and I place it over here. As you can see, I got the same amount as below. And what happens if I get my number sold all products, the naive inside it? Here we go. And then you see that the numbers differ. So what's happening over here? It has all to do with our filter context and our query context. Let's first start at the below one. In the below one, we say, okay, whatever happens, we are filtering on the product column and also on the other side the product column. So what happens is that whatever I do in this thing, my product column will be made free of any filter. So in both sides, whether I'm looking at this one, which just does only the product column, as you can see, I have only the product column over here, will both, whether it's all product or product column, both are the same, and that means that both will be filtered on the product. But what happens in the above one? If we look at all products, that's the one, this one, we say, well, whatever filter there will be on the product, whether it's on the column product or on the column product or on the column category, all filters will be removed. That means that whatever I do, in this case, I get the total because it's all products. But if I look at the native one over here and I say I remove all from the product column, that means that the filter I set in the category on furniture here will still be applicable. And in that case, it means that my query context over here, by choosing another column to filter, will change the results of the number sold products native, whether it's all products or simply only the column. And I hope this will give you a much more understanding that results can differ whether you have a query context, and it even differs if you use a certain type of filtering queries. So, context and table functions. As said before, if you find an X at the end of the name of a measure, it's a table function. And table functions in itself are one of the most powerful calculation options you have. And why? Because when you're working with it, you have different contexts in it. It can be a row context, it can be a query context, or it might be a filter context. And combining those makes it a very, very powerful instrument. So, look at our formula. It says sales total, and it uses the function SumX, and the first attribute is a table, in this case, the sales table. And the second attribute says from that sales table, I like to multiply my unit price with my sales number. And so I got my total sales with it. It's about the same as we did with the calculated column, but performance-wise, this is the best solution. But what does it take, this function? Let's first start at the beginning. The first thing is that my sales total will be executed in the query context. So you can filter it anyway, whatever you want. Keep in mind, it says in brackets, if this is a measure. If it's not a measure, it might not work in the way you think it works. So the next part is that I look at my sales. And the sales again is also executed in the query context. And that could be filtered with something. So if I say, for instance, my sales, where my sales amount is larger than 100, then only those sales will be used in my calculation. Again, this dynamically filtered table is so powerful. And the last part, and here we change things, if we're going to look at the second argument, sales unit price multiplied by my sales numbers, that will be executed in the row context for each row. And in this case, for each row in the table sales, because I take the table sales as my point of focus. But if I have a filtered table inside it, it will be only executed on the filtered rows for my first table. Again, this concept changes the way you can work within Power BI. So stay focused. So, and in this demo, we go to look at table functions versus a calculate function. As you can see here, I simply got a table which has my regions and my sales total. And my sales total is a measure. And the measure looks like this. It's the sum X of my sales, and I multiply my sales number with my sales unit price. So if I have made two other measures, sales above 10 in the form of a calculate, and a table above 10 in the form as a table function. Now let's look at both different. So the sales above 10, this one, I'll add, and as you can see over here, it is not the same amount. That's normal, because in the calculate we'll say, well, I only want my sales table number column be above the 10. And I've done the same in my sales above 10 in the table function. And adding that one with it, you can see that the results are completely the same. But keep in mind, there is something behind it. If I look at the calculate function over here, you can see I will calculate my sales total. And my sales total, as you can see, was the total which I computed over there. And my sales, he looks at the sales number above the 10. That means that it will go in my sales table for each row and search for each row whether the sales number is above the 10. So if I have a sales table for 4 million rows, all 4 million rows will be evaluated before the results can be computed. The other one is the sales above 10 is a table function. And here I use the sumx because I want, again, sum it. But before I do anything, I filtered my sales table, my sales numbers that must be larger than 10. So I create a virtual table with only the rows that are above the 10. And this is much faster because filtering is what Power BI can do best. So before I filter a table on the elements I want. And from that table, I want my sales unit price multiplied by my sales number. And as you can see, the result is the same. The second one, the table function, should be faster with even more large number of rows. The filtering will be faster than the calculating. Keep it in mind. In this demo of context, we use one DAX measure where we specifically look at the different contexts in which the formula works. So before we can go to the formula, let's look what the requirements for this project is. It's all about a company that is selling large projects. And what we know about the projects, they are categorized in project types. For each project, we know which roles are needed, how many FTEs per role, and when these FTEs are needed, in month of the project start and in the places where the projects are. And what we want to solve in this one formula is this. Given a number of projects sold, how many full-time equivalents per role does our company need to have? And before we can give an answer to this question, we first start to look at what are the tables we use. So here we have a look at our relationship scheme. As you can see, we have a one project table, which is our fact table, and they are connected with the location, project type, the table with the needed FTEs, and the roles. And as you can see, we also use another table which has the month in it and it has the date. And surprisingly, there is no relationship between the project start date or something like that with the date itself. Later on, we will explain why this is as it is. Let's have a quick look at our tables. Here we go. This is our month table. As you can see, it's all months and years with the last day of that month. That one is connected to our dates, the ones who are over here. And the dates table is a normal dates table which has all the dates unique in it, all kinds of variances with it, how we will look through things. We have a table with the needed FTEs, which is nothing more than it says this is my project type, the month in which it plays. As you can see, this will be a project that has 60 months to go. The number of FTEs and the role which in it. And we also have a location table which gives us just a couple of locations, not more of that. And we're going to use that one more or less for a filter one. We also got a project table, it's this one, and it gives us the projects we have and to which location it has been done, which is the start date, and a number column. We got a project type, and it just is a number of projects we have, and we have the roles, and it will display the roles we have. And this is the result table we want to see. As you can see here, I got the location, and within the location I have the Amsterdam selected, and it will give me the FTEs for Amsterdam in total for each month. And as you can see, I got a slicer on Amsterdam and a slicer on 2018. And if I go a little bit further over here, by just down drilling on my location, then you will see that there will be the projects with it. And if I down drill with the project, the next one I can see that I have my projects with the roles on it. And this is the table we want to look at. Changing it to, for instance, to London, and everything will be changed to London. It seems to be a bit hard, but this is just one formula. And this is the DAX measure we're looking at. As you can see, there are 3 table functions used in it. An average x and twice a sum x. Later on, I'll explain every step of this formula to let you understand why we have built it in this way. Please be aware that if you want to become a Power DAX user, these kinds of functions need to be in your toolkit. So let's dive in this measure step by step. And the first step, as you can see, says my average X month. And keep in mind that we want to know per month what the number of FTAs are. So we start with that one, and we use the average X table function in order to step through that table and get every month, end of the month, within our calculation. And that's the function of the dedicated month table. The second step is that we look at the distribution of the rows and FTAs based on the project type. So we first have the month, and then we have the project type. And now it's interesting to see what happens, because the average month itself is in query context. But since sumX is the second argument of the average X, that means that that will be changed in the row context in months. And here you see that you need to keep track of what is the context I'm looking at. So in the third step, we take each combination in our project table and combine that with the FTAs we needed. We use the cross joint for it. That's a very useful DAX function, but keep in mind that it is costly. If you have large tables, it will need to have time to calculate all possible rows. But in this case, it's very useful. Again, it's wrapped up in a sumX in order just to keep our the table we create, the cross joint table, as part of the table function. The things you need to keep in mind with this is what's happening to our context. As said, in the average X, we start in a query context, but with the sumX, although it's the second argument, is my project type still in row context. And the last one, and you needn't be surprised, although we start with the sumX, and you might expect that it is the query context we are in. No, we're still in a second argument of a sumX, so this row context in project and project needed in the first argument is a row context. A number of projects times my sum FTAs is of course a row context. In our formula, we have created a cross joint project FTA needed combined table, but we need to add two filter elements to extract the exact rows for our calculation. And the first one is that look at the end of the month month date table and compare it with the end of the month of my project start date. If they're equal to each other, that's the row you need to take. And in that case, we also reflect to our average X month table and our sumX project type table. If you have selected that one, the other selection we have over here is that we need to select then the FTA needed in the month. So we add this formula in our visualization, and obviously something went wrong. The numbers can't be correct. So looking at this, what went wrong? So to solve these problems, we need to go to our formula and realize in what way, in what context our DAX functions will work. So the first thing we had was that we started in a query context. But the second argument of my sum project type changed that context to a row context. And in the last one, there where we calculate our number of projects times the sum FTA, we still are in a row context. And remember, in a row context, there is no way that a relationship can propagate your filter. So whatever it is, it's just a single row. And that means we got totals and not the ones we had to filter. The solution lies in altering our context. As said, what we need to do is we need to change the row context from the last summix to a filter context. And as you may be aware, we have calculate for it. So we use, in this case, calculate to create a filter context, and we don't have a second argument with calculate, because we only want to change the context from row context to filter context. That means also that if you look at the filter which creates our dynamic table cannot use multiple arguments in the first part, then it needs to have one argument. That's why we have to add the max to a table. It cannot be a table, it needs to be a single value. And adding this, add your formula, you change your context, and this formula will now work as expected. So this will end my session. Thank you very much for watching. I'll end at the very end of my session with some takeaways. I hope you enjoyed it.